All right, here it is. We can basically use the complement rule, not the traditional age. This is the traditional age. So yeah, sure, we could add these up, but we could also just use that to our advantage. Okay, so 1 minus 0.57, 0.53 is the answer. Okay, let's see what we're learning here about mutually exclusive events and these rules. This is the check your understanding on page 309. Pause, try all three of these, and then I'll give you some feedback. Go ahead. All right, here we go. In your own words, something about the fact that you can't have cholesterol 240 or above and between this range at the same time. Okay, or you could say the probability of A and B happening at the same time is equal to 0. All right, so here's the part B. Here's my interpretation. Go ahead and read that. You could say it that way, or combined is fine. You know, a level above 200 will also explain that. Okay, and then what is the probability of A or B? It's 0.45. Okay, and here's part C. Okay, let's get into two-way tables. Example 7, we're going to use a two-way table, and actually in example 8, we're going to create one. I think I mentioned we're not going to do that today, but we'll finish through example 8. Okay, read this to yourself. Okay, so 5 people are part of the sample. Okay, in a two-way table, you can always find that here. You got kind of conditional probability and you have marginal probability. So these are the conditions in here, these cells, and then here's the margins, right? So out of these 500 people, they're either high school graduates, 310, or they're not. Those should add up to 500. Either they are a homeowner, 340, or they're not. That should add up to 500. And then these are the conditions inside, right? This is a homeowner. Out of this 340, some of them were high school graduates and some of them were not. So that's how you break that down. These add up to 340. Okay, not a homeowner, 89 plus 71 adds up to 160. So there's how you kind of read them and how these are broken down. Let's use these variables for the next few examples. Write this down. That G, this event, will be high school graduate, and then let's let event H be owns a home. Okay. All right, so suppose we choose a member of the sample at random. So out of this 500 people, we randomly grab one. Find the probability that a member is a high school graduate. Okay. So if they're a high school graduate, we're going to use the marginal one. This one's a pretty easy one. Okay. So we get 310 out of the 500. Oh, I'm going to add something to part B. I think I did to yours. Hopefully I did. He's a high school graduate and owns a home. Yes, I did. Okay. So what if they're a high school graduate and they own a home? So high school graduate and they're a homeowner. 221 people fit both of those, right? They're kind of in between the crosshairs. So that's 221 out of 500. All right, C. This says is a high school graduate or owns a home. Okay, so this one's going to be G or H. This one was G and H. Okay, this one's G or H. All right, so we're going to use that mutually exclusive event. We're going to add them together, that formula. Okay, it's basically going to be equal to the probability of G plus the probability of H minus the overlap. Now, this is actually the first time we've seen one that is not mutually exclusive. Okay, let me pause for a moment and show you that formula. Hold on. Okay, so let's just say I use that old addition rule that we did on the previous page. Probability of a graduate was 310 out of 500. Okay, these people here. Then plus the probability of owning a home. So if you own a home, it was 340 out of 500. Wait a minute. That's 650 out of 500. That's not a real probability. Well, what really happened here? Problem is, these are not mutually exclusive. For example, the high school graduates that were 310, and then this 340, if you kind of look at that, I double counted this group of kids. 221 was part of that 340, and 221 was part of this 310. So I double counted 221. Okay, so that's why this rule says we got to take back out the overlap. Okay, let me show you the next page. This is where this rule is at. If we look at this, it's called the general addition rule for two events. Probability of A or B is equal to probability of A plus probability of B minus A and B. You always have to use this rule when they're not mutually exclusive. If they are mutually exclusive, we're good to go. We already did that, right? Probability of rolling a 5 and a rolling a 6 from the dice, that's all we needed. But if there's overlap, or they're not mutually exclusive, we have to do this. Okay, this is in your yellow packet too on your AP Stats formula sheet. All right, so here's the work. There's the 310 plus the 340 minus the 221, the G and H. So we get 429 out of 500, 86% chance. Okay? All right, let's go to the next page. Okay, some follow-up reading here that you should do. All right, here's how the rule looks like, or what it looks like on your formula sheet. They're using the union symbol from like Venn diagrams. So this means or, and then if it's upside down, it means and. Okay, so there it is. All right, you can really use this for mutually exclusive events as well. So for example, what was the probability of getting a 5? It was 4 out of 36. Plus getting a 6, we had 5 out of 36 for that. And then what's the probability of getting a 5 and a 36? Or, I'm sorry, a sum of 5 and a sum of 6? It was 0. That'd be impossible, right? They're mutually exclusive. You can't get a sum of 5 and 6 at the same time. So this really works for when they are mutually exclusive as well, as long as you remember that's 0. Okay? All right, so here we go. Go ahead and read example 8. I'll pause for a moment and let you do that. Okay, two-way tables are a lot of fun. I think it really helps you too with answering some questions on it. So here we go. I'm going to put event B, getting a heart, down here. You could flip-flop these if you wanted to. You could have event A here, event B there. So we've got hearts and we've got others, right, or non-hearts. So non-hearts. The other event was A, getting a face card. So we have event A, face card. And then we got non-face cards. Non-face cards. Okay, and then these are your kind of totals. If you want to write the word total, you can here. Total's down here. And we know there's 52 cards total. Okay, so put 52 in the bottom right. It's usually easier to start on the outside than work our way in. So for example, face cards, what's the total amount of face cards? Jack, queen, and king, then there's 4 suits. So 3 times 4 is 12. Okay, remember these have to add up to 52. So it's 40, use the complement rule. How about hearts? There's 13 of each suit, so there's 13 that are hearts. Okay, if I take that away from 52, I get 39. Okay, now just break this down too, cell by cell. How many hearts do I have that are face cards of these 12? Well, there's 3 that are heart face cards, and then there's 9 that aren't. Make sure they add to 12. Okay, let's go this way. It doesn't matter which way you go. I just saw the 9 and 39, and I wanted to quickly make that 30. Add to 39. Okay, that means I have 30 non-heart, non-face cards. That totals 40, so this one must be 10. Okay, works in every direction, right? My numbers are checking out. All right, so there's a two-way table that displays these two events, hearts and face cards. So what's the probability of A and B? So randomly selecting a card, what's the probability that it's a face card and a heart? These three. So 3 out of 52, which is approximately equal to 0.06. Okay, part C. Explain why probability of A or B is not equal to the probability of A plus B. Okay, so why is it not equal? Why can I not just add them together? Well, probability of A or B, if I add those together, they're not going to be mutually exclusive. Okay, so probability of A is 12 out of 52, plus the probability of B is 13 out of 52. Okay, so that gives me 25 out of 52. So is that the real probability of drawing a face card or a heart? Remember, we can draw a card that is a face card and a heart at the same time. All right. So why are these not equal? It's because A and B are not mutually exclusive. They can happen at the same time. Okay. Like the Queen of Hearts, right? The Queen of Hearts is an example of why they're not mutually exclusive. Okay. All right. So we need to use this other rule. We need to use this. Probability of A plus the probability of B minus the probability of A and B. So probability of A plus B minus the ones I double counted, right? Because when I got this 12 and then I got this 13, what happened? I counted the 9 and the 10 individually, but I actually counted the 3 twice. Okay, so we got to take one of them back out. So the A and B is the 3 out of 52. Okay, so we end up with 22 out of 52. Okay, that's a pretty good start. All right, I want you to use these notes to your advantage as you work through the OTI. It's about a day and a half worth of work. I usually spend 3 days in this section. We're going to spend only 2 days. So good luck, work hard at it, and get it turned in by the due date. Take care.